everyone. So today we'll discuss about an introduction to research data management and the data management plans. We will be three today to present. There is me, Jonathan Lebomber, Joël Westerbeek, and Alexis Lucas. The presentation will be divided in three parts. First of all, we will discuss about research data management. Then we will present you the data management plan tools. And at the end, there will be an exercise on the data management plans online. So, first of all, I will start by why it's important to have a good data management. The main reason to have a good data management, there is different reasons, but one very important, it's simply for you to get visible and to promote yourself. So, having a good research data management have a lot of advantages for researchers. So I will not read everything, you have the presentation, but it will help you to plan your research, to help you to get access to other data that are collected by the others, to share your data with your partners, with the scientific communities. You will gain in visibility, the transparency. It's very important also in science to show the data you use and the code you use to have your results. There is a lot of advantages to have a good research data management. That's why today we are here to speak about RDM. Also, having a good research data management will increase your skills and your knowledge in the research process. Therefore, it's very important if you are to put your skill in your CV and your resume, and maybe when you apply for fundings or a research proposal. You can explain that you have, for example, good knowledge in the research process. You have knowledge in the data creation, ID skill, in codings, some specific disciplinary tools, device, programs, and so on. So having a good research data management will be important to share the data and to have full possibilities of the data, but also it's very helpful for you to promote yourself and to get visible. The research data management is very important today because we are in a global internal research context. I'm sure you are all aware of that, but also because now there is a lot of data about everything, so we have to manage a very huge amount of data. It will help to improve the trust in science. There is a lot of crisis today about science. There is a lot of people who don't believe in science anymore. There is a lot of problems with science. I'm sure you're aware of that. Also, in some field, I'm from human sciences, and sometimes there is some problem about replicability in science. That's why sharing your data is very important to prove your findings. We are speaking more about open access, open data. It will help you to meet researchers' needs. And finally, meet the excellence in research. But first of all, we have to define what is the data. So data can be defined as a factual records used as primary sources for scientific researchers, and that are commonly accepted in the scientific communities as necessary to validate research findings. So it was a common definition. That means that data can take a lot of forms and present in different formats. For example, you can have experimental data, observational data, geospatial. Someone here, it's about gravitational data. I don't even imagine what it is from my perspective. So there is a lot of data. Therefore, we have to have common knowledge, common practices to share the data. When we want to share the data, there is different way to do it. very common view is the open the data, just open the data and give access. So we will divide two things, the fair data and the open data. Open data is seen as data that can be freely used and reused, redistributed by anyone. There is no restriction. So anyone can access the data and use the data. If you want to work in an open data, you have to make data available and accessible. That means that the data can be accessed by anyone, most of the time downloaded by internet. And the data must be available in a convenient and modifiable format. So you can change the data and you can access and open the data, of course. That will be used in redistribution. So you can, the idea here is you can mix the data with other data sets. So you can increase the number of data. You can use the data of others to improve your own data. And there is the universal participation. So everyone can, must be able to use, reuse, and redistribute your data. So there is no restriction. So it's for private sector, public sector, academics. Anyone can access the data.
What do you mean by modifiable? Because if it's, I mean, the result of an experiment, you don't want people to just change the result, right?
Yes, for example, for example, if you compile the data and create the project on this ground.
Good observation.
Yes.
You have some kind of data set of observation, but you are like, okay, we need more experiments to more for such a small population.
And then you add stuff. Okay.
It's okay. So you have
maybe if I can.
Yes.
But it's okay to put some kind of a check that your data is not be modified or stuff like that, right? So
in open access, full open access.
Yeah.
In fact, yeah.
Well, is it okay if I say that's the data, and here is a checksum or a way to check if the data is still valid?
Yeah.
And then you say, I mean, if after that you modify them with your result, but I don't trust it anymore in a way. But they say that that's the data, and that's a way to check that no one may have changed the data.
Yes, but Jonathan will explain further the documentation, which avoids to misinterpret the data while they are used by other people. They have to be documented.
So open data, full open access to the data, full open data, it's not very the most practical way, the best way in science. So that's why we have FAIR principle. So that means when you share data with others, the data should be findable, accessible, interoperable, and reusable. That means that findable, the first step, it's when you want to reuse data. Data, it's easy to find them, and there is the metadata and the data. So it should be easy to find for human and computer. So most of the time, it's based on the website. Accessible only once the user finds the required data, she needs or he may need to know how they can access with authentication and authorization. So you have authorization, you can grant authorization in the FAIR principle. Interoperable, it means that your data can be integrated with other data. It's easy to reuse in variety of context. So you can mix the data with other and reusable. The data should be well described. So you have a clear explanation of the data. You have the metadata also, and to help you to replicate the analysis. There is a resume about different ID. Findable, it will be pushed in a repository. I will give you some example. with a persistent identifier. So that means that when you share the data, you will have, technically, you should be always cite for the data, and you will have some metadata to understand the data. Accessible, it's a standard protocol. Interoperable, there is some vocabulary to describe data, there is connection with other data, and it's machine readable, so you can access the data easily and read the data with some common software. And reusable, there is a license that will allow you to use the data in some So the ideas when you share the data, it's to be as open as possible, but as close as necessary. It's not a black and white situation, so you don't have closed data and full open data. There is some different degrees of opening, and that's why we have the FAIR principle, FAIR data. You should use closed data. You should not share your data in some very specific situation. For example, if you have personal data in it, so the name of individual, for example, or if you can identify someone in the data. If you have sensitive data, Alex will explain, I think, in the GDPR, confidential data, or if the data are subject to secrecy, of course. There is a third-party data. Data is protected by copyright or database rights. Data with commercial or economical valorization. But for example, for a patent, you can open data. Data that infringe prior commitment related to a data share agreement, like a consortium or informed consentment. So, in resume, between all the data we can manage, all data accessible in science, for example, there is a lot of data. We want to share some of them. Some of them are based on the FAIR principle, and there is also open data. There is a coverage between FAIR data and open data, and here today we are discussing about this kind of data. There is data correctly managed, and we want to share with others with good principles. So we are there. And of course, there is data that are open, but not reusable, not manageable, data that we can do nothing with it. So here today we are more in this area. So when you have data, when you want to share data, the first thing is to have a data. So you can create your own data set. You can make an experiment, for example, to create your own data, or you can use data from the others. So the research data management plan, in fact, will follow the research life cycle. When you want to create a project, the first thing is to create the project and to write the founds. Then you will collect or create the data. Then you have the analyze. You will analyze the data, then publish and promote your work by a publication, a symposium, conferences, and so on. In fact, RDM, it's very close to this cycle. Because when you want to create a project, it's very recommended to create the data management plan to go on the MPR guide, for example, to start your project. When you will collect the data, you have to collect, to store and protect the data you have collected. Also, during the analysis part, you have to store and protect the data. Finally, you will have to publish and share the data. So the RDM cycle is very close to the research life cycles. So why to use secondary data? Secondary data is data you don't create. It's data you can collect from others. It can be very interesting at for different reasons. For example, when you create your own project, you can use it for your introduction to discuss the data, to build your own theory, to build your own case from several data sets. You can test your hypothesis. It can save time, save money, because limit the data collection expense. You can just have to collect data from the other. And also sometimes if you have your own data, you can compare your own data with data from the others, from secondary sources. So using secondary sources is very important. And sometimes it's also requirement for to have findings in some project. So to have secondary data, you have to go on the data repository. So what is a data repository? It's more of the time it's an online platform that it's used to deposit and complete data sets. The data will be associated with metadata and documentation. The data will be stored for short to medium term, like 5, 10, or 15 years. It's not only to archive the data, it's very to open and to share the data with others. And it will contribute to make your data fair, so findable, accessible, reusable, and interoperable. You have here some example of repository. I don't put the UC repository, but we have the Dataverse. It's a very specific, it's a repository created by UC. In the research data management, you have to manage your own data, the data you will have. Here it's a part that we have right with the SMCS, the support en méthodologie calcul statistique, platform from UC Louvain to help you for statistical analysis and also with data management. So sometimes when you want to create your own data, it's not created directly by a computer. You have to enter manually your data. Like for example, in medical sector, sometimes you take some parameters of your patient, so you have to enter the data on your spreadsheet. So it's really common to use data entry screen, so to specify what data you will enter on what format. So you will have to use control vocabularies and use, for example, a list to minimize the manual data entry. And to have detailed labeling of variable to avoid confusion and mistakes. When you have your data, it's very important to check a small sample of your data to verify some common mistakes. Run some analysis like frequencies, mean, range, clustering to detect error or anomal values, to be sure that the data is correct, and sometimes you can review your data with others to compare the data. Therefore, if there is some anomal values, some mistakes, you have to define what you will do with the missing value, how they are encoded. Sometimes there is different types of missing values. Like for example, in a survey, if you don't want to answer or if you are unable to answer, there is different types of missing values. Like for example, if I ask you a question about weddings, but you are not married, it's not useful. So there is not a missing value. You are not able to answer. So I have to be able to compare. But to be sure that your individual response is in line, not in columns, you have the name of the columns on each columns, and it's only on one line, but on different lines. You have to withdraw useless lines, columns, empty columns, for example. You have to check the data importation to be sure that the same before and after the importation. Sometimes we have some issue with the encodings, like for example, for text, different types of encodings, UTF-8, UTF-7, and so on. So you have to be sure that everything is still in place. Maybe look for duplicate observation and look for consistency between your variables. So just to check the data before using them, it's a very basic principle. After that, you have to organize the data. So organizing your own data is sometimes a mess. So there is some guideline you can follow, maybe in your labs or entities, maybe there can be existing procedures about how to store your data and to manage your files. You have to define how to name correctly the files, because I have some example after that. You have to be consistent between your works, so all the time use the same procedures. Maybe separate the ongoing work and the complete work for easier. It can be easier to find the data, make some backups, review the record sometimes to be sure that everything is in place, and delete the not necessary files. Here, for example, an example. It's two different times of my own works. For example, here it's from my thesis. It was when I was a young researcher. I have a lot of files put in not specific orders. I have namings that's not very helpful. Here, for example, I have a revised version, old version for reviewing, and at one point I don't remember what is the old between the revised version, so I have to check all the time the data. So the file organization here, it's very messy. And now I try to have a more organized data. And my way to organize my data is always to put the date, byte, years, month, and day, and then a brief title of my folders. Also for the file namings, it's very important to be consistent in the file naming also, using vocabularies, punctuation. You have to define the way you want to work. You have a common language and try to be very easy to understand. Put dates in your file names. Precise for the revision procedure, which is the version, and maybe the name of the people who work on the version. Create new files when you have big change inside the data. You change, for example, the theoretical part of the paper, for example. And you have to define, if you work in team, who is responsible for using the word final. Because another example, here, I have here some part of my own thesis, and I have theoretical part, well advanced, endings, another endings, almost endings, read by someone, and the almost endings by them. So once again, when I write my thesis, I don't have any kind of file namings procedure. So once again, it's very messy. And sometimes we have some data with final, real final, and so on. So try to be very consistent to organize your own data. And if you have any need, specific problem with data management, you can contact the SMCS, the website. Now it's Alexis.
I think that's what makes the sound.
So a little bit on data storage and protection. So first, avoid storing your data on your laptop or phone. Usually, we recommend to keep a few different copies of your data just in case your laptop is stolen and you had your data in it, and it's over. We recommend also to keep the raw data, so the data you collected but didn't clean or treated yet, because maybe you need to go back to that. Your clean data that you use for your analysis, and another version for publication. We'll explain a little bit why the clean data and the data for publication can be a little bit different, but typically there are personal data that you cannot publish, but that were useful for some part of your analysis. it's important to keep both versions. And finally, you can use also encryption software like Wrapup, which is usually recommended because it's also free software and relatively safe, especially if you have some sensitive data and something that you really don't want people to see. And finally, don't forget the physical analog data. Typically, we have a lot of researchers who take notes of interview with notebooks of stuff they see on the field. That's also data that can be useful, so you can digitize it. You can just actually photograph it and share it, but it's not the best way. That's it. For storage, there's also transfer. When you transfer your data, it's also a sensitive part, so try to be careful as well not to transfer it using something that is not safe. Typically, we transfer stuff like that. You can share it by mail, but sometimes it's too large. So check with your institution, your university, what is recommended, because it can be a little bit different from one to another. But use trusted peers. Don't use Dropbox or Google Drive. Usually, again, check. But again, there's no agreement between Iseluva and them, so usually they are not recommended. OneDrive is the one recommended for Iseluva. GDPR, so for transferring data, it's usually the easiest way. So GDPR a little bit. So it's a fundamental right. It's in the Charter of Fundamental Rights of the European Union. It's also in GDPR, which is the main regulation on data protection in the European Union. So it concerns all personal data, which is data related to a person, obviously, that is identifiable directly or indirectly. So for example, if you don't have specifically name, surname, but that you have a lot of information that can be grouped together to find back the person, that's still personal data. Even if just looking at one column, you can say, okay, that is this person, but taking a few different variables together, you can find back the person. An example, if you say male working at Iseluva in my street, okay, it's me. If you just have one of those information, you cannot find back the person. But if you have all of them together, that's personal data. So if you need to use personal data, you have to follow a few principles. The first one is lawfulness. So you have to have the right basis for treating personal data. We'll talk a little bit more about consent later, which is the most used. Other possibilities are legitimate interest. So, okay, legitimately, I need to use this, but it's not usually recommended. It can be a solution when consent is not possible, but it's very limited in what you can do with it. Or public interest, which has the same kind of issues. Fairness toward the data subject, that's obvious. Transparency, so they need to know that their data is processed by you. And purpose limitation, so you cannot collect data for one purpose and then use it for another purpose. You have to say exactly what you need to use it for and use it for that reason only. So there are some implications on the data storage part. For example, data minimization, which means that you can only collect and store the data that you need. So it means you cannot decide, okay, I'm going to make a survey and I'm going to ask people their religion, their political affiliation, and the labor union they are a member in. I don't know if it's going to be useful for me, but I'm just going to collect them and we'll see later. That is not minimization. That's collecting a lot of personal data, sensitive data, and you don't know why. So you need to really think before your survey, okay, what do I need exactly? Do I really need that to answer my question? And if you do, then yeah, you need to use it. But if you don't see, okay, maybe this one is not completely useful, maybe I can answer my question in using different data, less personal data, it's better to always use the less sensitive data. Accuracy, which is a bit in the ideal world, you have to keep your data accurate. So if someone changes something, you have to change it in your data. It's not always possible, but at least if your data subject, so the person who collected the data about, is telling you, okay, this is not true for me anymore, then in theory you have to change it in your data sets as far as possible and practicable. But yeah. Storage limitations, so that's kind of linked to data minimization, is that not only you have to collect the data that you need, but only for the period that you need the data. So once the data is not useful, in theory, you should remove it. There are some exceptions for archival, statistical purpose, that, okay, you can keep it for a longer time because the purpose is archival. A priori, it's going to be for a long time. But you still have to think, okay, do I really need, for how long do I need this data? Is it useful for archival or not? And if it's not useful for archival, certainly you can remove it. If it's useful, then it's a bit more complicated. Integrity and confidentiality. So you cannot share the data with random people, basically. And you cannot allow people to change your own data without control. So they cannot go in your data and change a political affiliation of someone, and then you go back to your data. It's not shared, but it's not the integrity part has been compromised. And finally, accountability. So it's basically what's written, compliance to documentation and responsibility. So you need to be accountable for that. There are in GDPR some categories of data that are called special categories of data, basically sensitive data. I put them here. It's kind of most of the time common sense, like, okay, sexual orientation is a sensitive data here. It's clear, trading and membership. And it's a little bit interesting because personal data is allowed as long as you respect the rules. Processing of the special categories are not allowed unless you respect a specific set of rules. So it's kind of reversed the default on the processing of those. There are exceptions so where you can process those data. One exception, for example, is public knowledge. Okay, I'm going to write an article on Wrapup. I know it's political opinion. You have the right to mention political opinions of Wrapup because we know what they are. Another exception that is quite important for research because it's, I think, the most common lawful basis for the processing of personal data is informed consent. So basically, you go with a consent form and they say, okay, you have the right to process my personal data. But even like that, you still have rules to respect. It's not like, okay, they told me I can process their personal data, so now I'm free to do whatever I want. First, the consent needs to be freely given, and it must be informed consent. So you cannot force them to sign, which is obviously, but informed part is not so easy, I think, because GDPR is quite complex. And informed means that you have to explain it to them in terms that are understandable for anyone, not just lawyer terms and stuff like that, but really easy to understand. So usually it's your DPO that will handle the writing of the consent form because it's really not that simple to write complex laws into very simple terms without losing any part of it. They have a right to know that they are participating in research, which can be a little bit complicated sometimes. We have, for example, people in anthropology that have to observe by participating in a group. Of course, when you start by participating, by bringing your consent forms for everyone, it kind of changes the relationship you will have with them. Again, there are some solutions, but that's for you to check. But usually they have to know that they are participating in research. Informed consent should be used in research with human subjects. That's also kind of obvious. We are talking a little bit earlier that someone is working on space gravitational data. Yeah, you do not need to use a consent form. Planets don't care, I guess. You have to explain why you collect the data, how it will be used, how it will be stored, and who they can contact. And that's really important because I will jump to the last point now. Consent can be withdrawn at any point. So they can contact you and say, remove my data from your data sets now, and you have to do it. Again, there are some exceptions, including for statistical research purposes, for archival, where we can still keep the data, but it's very restrictive. So by default, consider them, they can decide to remove the data anytime they want. And be prepared for that and give them a contact that is on kind of long term. So if you are doing a PhD, maybe give the thesis director that will be there for a long time because they can ask in 10 years and or use your private email address. I don't know that. Again, check this for for everything legal and not for the law.
Is it okay then if someone requests that their information is withdrawn, that we in turn remove the privileges that they had thanks to this information? For instance, we request that every user is registered to a mailing list because that's our main way of distributing information. And so when they request to be removed, we explain that in turn their account is cancelled.
Yeah, there's also other lawful basis for processing personal data that I didn't mention, but one of them is as part of a requirement for a contract. So in that case, I guess it's following that. Again, I'm not a lawyer, so maybe check to be sure, but then yeah, if you, for example, ask HR in Louvain to remove your personal data, they will probably tell you, okay, but then you have to leave the company because it's part of the contract that we need to know who you are to hire you. I suppose it's kind of a similar situation. So yeah, it's a bit a special case. And finally, if you plan on sharing or publishing the data, you should also mention it in the consent form, which I suppose is kind of obvious. But I know I will give the place to you.
So, hello everyone. I propose you to discuss about a further part of research data management, which is publishing and sharing data. So, the first element we need to publish, to share data, is a data repository. It's a reminder because Jonathan has explained what is a data repository. So here the purpose is to publish, share, and or preserve them. And I've written and or because sometimes data cannot be published. There are closed data, as explained Jonathan. There are different degrees of data sharing, from totally open data to closed data and with some kind of restricted access for data. So a data repository is a database infrastructure that compiles, manages, and gives access to several elements, of course, data, but also associated metadata and documentation. Metadata is very important in order to make your data findable. The FAIR principle, the data are findable. And documentation is also very important in regard of the FAIR principles, because it gives the users all the elements to make data intelligible and to interpret correctly the data. So the data repository with all these elements contribute to make your data fair, findable, accessible, reusable, and interoperable. Data repository is different from data storage. Data repository, it's you have to deposit your data at the end of your research to share it in open or fair mode. It's different from storage, so a backup of your data during the research. It's also different from long-term archiving, very long-term archiving, and it can be discussed with the archive service, for example, here in UC Louvain. And a data repository, it's different from a publication repository. A data repository, of course, it's for open data, and a publication repository is for open access, for example, articles in journal. Yes, here a data repository in UC Louvain, we have Dataverse. I will explain later. And publication repository is DIAL in UC Louvain. There are different types, different categories of data repositories. First of all, you have general purpose or multidisciplinary data repository. They accept a wide range of data, and all disciplines are accepted. General purpose, for example, you have Zenodo, OpenAir, OSF, or other repository. Secondly, you have domain specific, this or disciplinary repository. They focus on specific types of data or data from specific research domain. So here it's a repository with elements specific to a discipline. So they are widely recognized by the community, and generally it's a very interesting repository because it's based on well-defined disciplinary standards. So it uses standards from the discipline. And you have also your institutional repository. So if no repository exists or is recommended in your discipline, you can use your institutional repository. Here in UC Louvain is Dataverse. Other institutional repository, for example, it's SODA, the Belgian Federal Data Archive Service. So general, disciplinary, institutional, but also sometimes publishers have a platform to put your data. And now, how can you find a data repository? There are repository registries or knowledge base. Its elements very interesting because they will synthesize data and registries, repository from a big number of sources, though they synthesize this element often via manual curation, and then they provide a list of different data repositories. Sometimes you can browse by discipline. in these registries, and they offer facilities to search and to browse a description of different data repositories. It's a good starting point. If you don't know which repository exists in your discipline, it's a very good starting point to identify a suitable repository for your discipline and for your specific data. Here it's several examples of registries to identify a repository, data repository, which is suitable for your data. You have ReFree data, so it's the registry of research data repositories. It's a directory listing more than 2,000 repositories, so it's a huge element, and it allows you to make a research and to refine your research while using a diversity of filters. So it's very practical. You have OAD, Open Access Directory. It's a wiki page listing repository by discipline. And then you have Contrast C. It allows you to search for certified repositories. For example, if your project is funded by Horizon Europe, the European Commission, it's necessary to have a certified repositories. In France, the Comité pour la Science Ouverte, the college of this committee has defined a list of several criteria. It's a list of exclusion criteria for selecting a trusted thematic repository. So what do you have to check while choosing a repository? For example, you find a repository in the registries. What do you have to check to identify the very good and trusted repository? So the first point is there or is there not a moderation of deposits? No moderation of deposit, do not select this type of repository. There are no permanent identifier. It's linked to the FAIR principle. If you don't have an identifier, your data are not findable on the other research. If you have no guarantee of the continuity of the infrastructure, the access principle in FAIR data implies that data are in a sustainable way. They are available in a sustainable way. So it's important to have an infrastructure with a continuity. You have also to check the property right transfer. For example, if you publish your data in a publisher repository, it's important to know what do you keep as a property right on your data. There is also another of money, excessive pricing policy. The localization is very important regarding GDPR, which I've just been explained. If the localization of data is outside the European Union, there are very big risks that it's not compliant with GDPR, so do not select this type of repository. And finally, if the repository is restricted by institutional affiliation, if you have to take an affiliation to type of society, for example, if the repository is not open it's not compliant with the open data principle.
Do you know if GitHub is okay? On the previous slide, yes.
Sorry?
On the one previous slide, GitHub was written, but I was asking if it's fill all the criteria.
I don't know. I come from human sciences, so I can't answer this question. But you have the criteria, and you can check it for GitHub. I don't know for the moment, but I can check.
No, it's okay. I can check myself.
There is no balance fire.
I don't. Well, there's the hash, which is kind of.
I'm not sure it's.
But it's probably not at the same level.
A repository for code.
Yes.
For code, yes.
For code.
Well, code. I mean, code are part can be data. So.
Can be data.
Can be data. Yeah. But I'm sorry, it's not my discipline.
No, it's okay.
I'm not able to answer. Yes. In fact, not all of your data is necessarily intended for sharing. You store everything, but when you have a reflection on what can I share in my data, not necessarily is intended for sharing. You have to select the data set to be shared. And the Digital Curation Center has defined 5 steps to help you to decide what data to keep. There are different steps. Steps 1 is identifying the purpose that the data could fulfill. For example, it's important to share for further analysis or for validation of my data by other users, or for example, by reviewers of my paper. It's important to have to consider the potential reuse. What aims could the data meet? The second element is in identifying the data that must be kept, considering legal or policy compliance risk. So sometimes legislation implies that data must be kept. The step 3 is identify the data that should be kept, as it relates, for example, to a significant new research process, so new to discover, or for example, because it's in line with actual international preoccupation, international policy, or social concerns, etc. So, what data should be kept? The step 4 is to weigh up the costs. Which management costs have been already incurred, and how much more is affordable for you, for your laboratory or institute, for example, and where do the funds come from? So it's important because preparing data, selecting data to be shared, sometimes it can be costly. The steps 5 is to complete the data appraisal. So it's a summary, list the data that must, should, or could be retained to meet the reuse objective. Reusing data is always the most important principle regarding to open data. Here it's a summary, so it's a summary of what I've explained. Once you have decided what data to keep, then you assign a license on your data. A license in order to define the condition of reuse, what the user can do or cannot do, is not allowed to do with your data. First of all, maybe a few points about the copyright, the question of copyright. Copyright law stipulates that by default, any creative work is protected by copyright. This means that any person wishing to reproduce or to redistribute your work, your creative work, must request your authorization. So, in the copyright, the principle is the authorization of the author. Creative Commons license are open license. Open license, it's a juridical instrument which complements the copyright. What is it concretely? It's an authorization which is given by the author to use or to exploit his work, her work, under defined conditions. So the author grants certain rights in advance. It allows you to reuse in certain conditions that will be specified in the license. So, other element, that's the open license preserve the author's moral rights, so the right of authorship. So the authors grant in advance to the user the right to use, to redistribute, for example, or to share his work under a certain condition. We will explain the condition, but it keeps his right of authorship. That's the main concept of a Creative Commons license. So it's free legal tools that indicate what can be done or cannot be done with resources. Concretely, with a Creative Commons license, there are 6 licenses combining 4 elements. These elements are the attribution. You must give credit to the creator of the work concerned. It's always in all Creative Commons license, you have to cite the citation of the author. It's the attribution. The second element, is it possible to make a derivative work from my data, or not? So, ND means no derivative work, no modification. You must use the work unmodified in its entirety. No derivative or adaptation of the work are permitted. The third element is share-alike principle. It means that, yes, you can reuse my data, but you can share it under the same condition. For example, here our presentation is in CC BY license. You can use it, you can share it, but you can't modify the license. It's the share-alike principle. And finally, the last element is the commercial use. So reproduction is authorized, but you may not use the work for commercial purposes. And then on the basis of these four components, there are 6 Creative Commons license. They compile all the elements I've just explained. So you have the CC BY license. So CC BY, CC BY, it enables the user to distribute, remix, adapt, and build upon material, but the author must be credited. Is the more permissive license. Then you have the CC BY SA. You can use, you can mix, you can adapt, etc. But the author must be credited. It's a BY, and the license is necessarily the same as R. The CC BY ND, you can use, you can share, but no derivative work is authorized, and the author has to be credited. CC BY NC, the author has to be credited, and it can be used, reused, etc., but for non-commercial purposes. The CC BY NCSA, the author has to be credited. It's for non-commercial purposes, and you can change the license. It's the share right condition.
But if you can change the license, you can make the license so that you don't have to give credit to the authors, and therefore redistribute it without crediting anyone. No.
Sorry.
Right, if you can change the license,
yes,
then basically all the other terms doesn't mean anything, right? Mm-hmm. Because then you can republish the same work without saying you don't have to credit the author.
Yes, it's always, you have always to credit the author. Even if you, for example, you want to redistribute the work, you adapt the work with SA. You take, for example, the PowerPoint, you add elements, so it's modification, but it's not for commercial purposes, and you have to put it in the same condition as yours.
You can change the license, but as long as you still credit the original author.
Yes.
Okay.
Yes. Yes.
So there are still restrictions on how you use the license. Okay. Yeah. Okay. You can restrict more.
And I have a
yes,
question.
it's a more restrictive license.
Okay.
On CC BY SA.
Yeah.
So I share it under the same condition. Mm-hmm. Someone wants to share it again. So now they have to credit me and the original author.
Yes.
So every time it's shared again, there's another author to add to the list.
It's a good question, but I think yes. It's sharing the same license and with the mention of the different contributors. Is it? Oh, yes. Sometimes, and for example, when access to the data is restricted, there are different degrees of data sharing, open data, restricted or controlled data, and closed data. When the access of the data is restricted, it's necessary to define and to write a data sharing agreement rather than placing your data into an open license. So when it's restricted, you have to define the condition for sharing data. So what is a data sharing agreement? So it's a convention between the research partners and all third parties. It contains several information, the way data will be formatted, the way they will be reused and shared. So it defines the condition, how data can be reused and to which purpose. The DSA mentions data sources, ownership, and the partner's responsibilities. And of course, they can be, no, DSA can be different according to the type of your data. So it's not a standard data sharing agreement, but we can have difference. And to define a data sharing agreement, for example, if you put your data in the UC Louvain dataverse, you can choose open license, it's Creative Commons license. In dataverse UC Louvain, the license by default is CC by SA, so credit to the author and sharing with the same license. But also you can custom data sets. For example, if your data contains, for example, has a potential from commercialization, it's a restricted access. You can define conditions to have access to your data. For example, it's through an authorization procedure. You have to contact a person responsible, and all these elements could be added in the data sharing agreement and in the edit dataset terms in dataverse. You can also choose an embargo period, or sometimes it's required, for example, in your consortium agreement, or etc. So an embargo period, it's a limited period during which the data you have deposited are not open. You can deposit and defining a period of time during which no one can request access to your data. Frequently, this embargo period is defined in the consortium agreement. So why? What is the reason to put an embargo? The most frequently used reason is because you want to have time to publish in journals, for example, before sharing your data with the public. Can be an argument to have an embargo period. Or, for example, you have to choose a, no, it's not, for example, how you have to choose a reasonable duration. It can be for years and years. No, it can be a reasonable duration with a clear release date. And all these elements, also as a data sharing agreement, you can edit dataset terms in dataverse UC Louvain to add an embargo period. Once you have licensed your data, making a data sharing agreement, you have to document your data. It's very important to make your data intelligible for others and then reusable. It's very linked to the FAIR principle. So what is data documentation? Data documentation comprises contextual and descriptive information, and all these elements are needed to find, to understand, and to reuse your research data. Why is this needed? Why is it important to add documentation? Because it enables you to interpret your data at a later date. For example, 5 years after your PhD, if you don't have a clear documentation, it's very difficult to come back to your data and to interpret that. It makes data independently understandable. They are reusable. It makes a result independently reproducible. Here it's very important. It's one reproducibility is one of the fundamental principles underpinning open data. So it's very important to document your data with an objective of reproducibility. And then documenting your data helps avoid incorrect use or misinterpretation of your data. So documentation is very important. It's an essential step in making your data fair in order to reuse your data. When to start documenting your data, the principle is start gathering information as early as possible in your research and continue as the project process, but as early as possible. And how to document it? So the first step is to document the study, the project, all the context of the study and the project, and then specifically the data. And in fact, documentation can be captured in various ways. Documentation, it can be a research paper, a lab notebook, a codebook, or a separate README file you will add, for example, in your data repository. It can be annotated computer script, etc., etc. It can be in different formats. Here is a dataset sharing checklist. It's a final checklist to prepare your data for sharing according to FAIR principle. In fact, it's a big summary of what we have presented in data management. So before sharing your data, you have to check these elements. The data set to be shared are clearly defined. Okay. Not all data have to be shared. You have to define the data set that will be shared. Legal, ethical, and policy requirements are respected. For example, are my data compliant with GDPR if it contains personal data? Files are well organized and named, as Jonathan explained. Files are in sustainable and open format, not in proprietary format. An appropriate license has been chosen because it's important that the user has information about how he can or she can reuse. The access procedure has been defined. Is it open, closed, or restricted access to your data? Is an embargo period necessary? If your data are in restricted access, what is the authentication procedure? And if necessary, as a data sharing agreement been established, you have the data distribution right. If you work, for example, with partners, or if your data come from third parties, and the data are properly described and documented. Here is just a few words I had mentioned several times. Dataverse UC-Louvain. So Dataverse UC-Louvain, maybe you know it, this platform, everyone. Okay. So it's the open data infrastructure UC-Louvain. It's a service for UC-Louvain researcher. The objective is to preserve and share research data in open or fair mode. data are stored on a specific server of UC Louvain, which is managed by UC Louvain, and each research entity that's requested will have a free space of 1 terabyte. And for how long the data submitted are guaranteed to last for 15 years, and extension is possible, but with a financial contribution. But what is the main interest? What is the main advantage for a researcher to use Dataverse? Because data will be preserved in a sustainable way, are guaranteed to last for 5 years, as I just explained. A DOI is attributed to the data, so a persistent identifier. You can locate your data and it allows to reference your data. Depositing your data in the Dataverse with the DOI, it allows to code your data sets. Your data can be coded by other researchers, and sure, it makes your data visible. Even if your data are not shared publicly, even if it's restricted access, you put a flag on the research. This research has been done. I've done this work. Dataverse, it's very interesting because you can share data in open or fair mode. So as Jonathan explained, there are different degrees of data sharing. You can specify terms of access if it's restricted access. You can put a Creative Commons license. It's a CC by default, or you can specify condition of data reuse. You have the possibility of specifying an embargo. It's a secure infrastructure on server of UC Louvain, and you have a free space of 1 terabyte. Here is for data sharing. I don't know if you want just a little pause.
You want a little bit?
No, I don't know what is the
We still have, yeah, still have 30 minutes.
size.
So pause now. It's
Okay, so now a little bit about data management plan. I will say DMP often because it's a little bit too long. Do you all know what's a data management plan? No? Oh, yeah. So the idea is to make sure to preserve the data in a sustainable way. Okay, so it's the management tool for that, for the purpose. The idea is to describe how you will use the data, how you will treat the data, how you will keep the data, how the data will evolve, and at every step. So it's previously of the research, during the research, and after the research. The idea is to get the data ready for reuse and long-term preservation, and it's also a little bit a living document that can be updated during the research. But it's still usually very important to do it before the research for all the reasons we've presented before, because you need to think what data you will use, how you will use it, how you will store it before even starting the research. So who knows DMP Online? Okay, so not that much, but it's a tool provided by universities to prepare your DMP easily, because it can be a bit a long procedure with a lot of questions. So that's one tool they provided, so you can just follow every step and you have explanation on all steps on how to complete it. It's been created by a Digital Creation Center. It can be shared and edited by multiple partners, so it's also useful when you don't have all the information or you need to check with other people to make sure you are all on the same page. and it's currently up to date, so you have also all the information for RGPD. So the data management plan is very important for multiple reasons. Sometimes because it's required by the founders. In that case, it's not really a choice, it's just you have to do it. For example, Horizon Europe, ERC, BESPO, FNRS, they all ask you to make a DMP before starting your research. It's also very interesting for you, and I think that's not really always emphasized, because it's seen as just a mindless administrative procedure that you have to complete the forms and do all the stuff so everyone is happy, but it's really useful for you because you have to think about this question. You have to think, okay, do I really need that data? Okay, how will I store that data? Sometimes it's a legal requirement, sometimes it's really useful because you might collect data that you didn't actually need if you didn't plan it through before starting. So it's quite interesting. It's quite interesting as well because it will help you be more organized. So Jonathan talked a little bit about folders and file namings. That's typically kind of, I want to say stupid stuff, but that can be really, really annoying really fast. That's the kind of thing that will be really important to think before starting basically the DMP. It's also useful if you work in a group, because it means everyone will use the same standards, everyone knows how the data is used, by who, where the data is stored, how to access it, and stuff like that. And it also helps to say, okay, if there's a problem, you need to contact this person, I will take care of this part and check what everyone is responsible for in the chain. Again, I really insist it's really useful to complete it before starting, but it's a living document, so maybe you will have some surprises that happens, and you can just change, edit it, and keep it up to date. So it's basically just a long list of questions about every point. It's kind of a little bit of a checklist. Do not forget that, do not forget that, do not forget that, if you thought about that, stuff like that. There is a template UC20 as well, but it's really interesting if you want to check a little bit the different parts. So even if your funders doesn't provide with DMP format, you can use it for your personal use just to check that you really have an answer to each question of the DMP. There is 6 main part in the FNS template that we will look a little bit more in detail. That cannot follow the data lifecycle. It's data collection description. Okay, that's quite explicit, I think. Documentation, quality, storage and backup, ethical and legal requirements, data sharing and preservation, responsibilities and resources. What we suggest is that we try to, after the presentation, try to complete it for the first, third, and fifth part. So it's data collection description, data storage and backup, and data sharing and preservation. Check a little bit if you understand the question, because sometimes they are not completely clear. If you know how it applies to your data, and see if you can answer those questions. So this is an example of the FNRS DMP. It's quite just a list of questions. So okay, DMP online, the advantage is also that you have some guidance on the side. So when you have a question that is not always really clear, or that is really short and you don't know where to start, there is a list of sub-questions like, okay, how do you plan to collect your data? Okay, who are you going to ask your question and stuff like that, so you can really answer easily the question and not forget some kind of aspects of the question that might not be completely explicit. There are some simple answers, kind of standard, because some questions are basically the same answer for a lot of people. And you can customize it for everyone. So this is an example. The list of founders templates. So depending on who you use, it's not really easy to read there, but this is a list of founders templates, depending on those that require it, usually provide the templates. That's a little bit what I said. So there's always a guidance. You can see things on the side here. So you go on a question and you have on the side the explanation of the question and the details on how to answer the question. And you have an overview as well, so you can see all the section in advance, all the questions that you will have, and all the different parts. So especially GDPR and GDPR parts regarding personal data. Okay, exercise. So there's the so you can go on DMP online actually, and okay, DMP online for the you can log in. I think there's an access for all university in Wallonia.
Yes.
So you should all have access.
Then you go on the platform, you click on create a plan, just over there. Then you will arrive on this page. You select the funding organization FNRS, here, funding organization, and then the FNRS DMP template will appear automatically. And please, as we have just said, click, tick the box project for testing, practice, or educational purposes. It means that it's a fictive DMP with a purpose of exercises and not a validation from the authority. Is it okay for you? Once you are on the DMP template, so you have the project detail, the plan overview, and then when you are here on FNRS DMP, we suggest you think about strategy for managing your PhD or other research data, and complete or just imagine, just realize a draft of the following parts of the DMP: data description and collection or reuse, data storage and backup during the project, and data sharing and long-term preservation. I suggest you have yes,
15 minutes.
15 minutes just to browse the question, and then we will have just a little debrief on this.
Okay, so useful information. Some of it is mostly targeted lycée Louvain. Let's see, DMP online is the central basis for the DMP. Not surprised here. And for lycée Louvain again, you can contact Joël. She will answer all of your questions.
Yes. So data ambassadors are specialists of the management of the data specific to your discipline, the discipline of the institute. So it's a more specific disciplinary help to data management. I'm research data officer, but for whole the university. So I don't cover every discipline. So it's more for general advice, formulation of questions related to funders, etc. And you can also take contact with your research administration.
And you have a data protection officer in each university. So for questions that are really legal requirements, if you need some more clarifications and points also a good resource.